Hi, welcome back to LeetCode. So in this video, I am going to discuss the first and second problem from this weekly contest of 493. So both questions actually are same actually. Only difference is that the constant. So here actually you can see that the constant of, like in value can be from 1 to 10 to the 5. But in the question number 2, in the part 2, you can see that the n range can go up to 10 to the 15. So that's why we have to think about the optimal approach, right? So let's start from the optimal, the second question. So first of all, we will actually see the brute force approach, then actually try to optimize that. Okay. So what is the problem statement? Problem says that you are given an integer n, return the total number of commas used when writing all integers from 1 to n, inclusive, in standard number formatting. So in standard formatting, a comma is inserted after every 3 digits from the right. Okay. Numbers with fewer than 4 digits contain no commas. Okay. So let's say example, what they're trying to say. Suppose we actually have 9. So can I actually place any commas here? Actually, no. So the condition for actual comma is that we should actually have at least 3 digit in the right hand side. Then actually we can place comma here. So suppose we actually have only 3 digits. Suppose 999. Okay, this is one number. So can I actually place any comma here? No, because there is no digit in the left hand side of this comma, right? So that's why we can place only if there is at least four digits. 1, 2, 3, 4. Then actually we can place actually one comma, at least one comma, right? The condition is that we have at least 4 digits. Then actually we can place one comma, right? Now let's try to observe the output. So suppose actually only one digit, we cannot place any um, comma here. So here actually output is 0. So that means if n is equal to 9, okay, that means our number can go up to start from 1, then 2, 3, 4, 5, 6, in it can go up to 9. So we have to check each individual number, that how many actually commas is present here, 0. How many comma is present here, actually 0. Here actually how many comma actually is present, 0. Actually again 0. Here actually how many 0, 0. Sorry, comma, how many comma actually present, it is 0. Here actually 9, here also it is actually no comma. So our total 0 plus 0 plus 0 plus 0, it is ultimately 0. Got it? So that means we have to check all the numbers from 1 to n. Okay, then it will check that for each number how many comma is present, and we have to add that, and ultimately whatever the total number of commas I have seen, that we have to return that, right? So brute force approach is that when actually our range n value is 10 to the power 5, 10 to n is equal to 10 to the power 5 maximum, then it's how actually we can solve this problem. So we can actually iterate from all number from 1 to, and it can go up to 10 to the 5 maximum. Worst case, here actually I'm discussing only about the worst case. So it can go up to 10 to the 5. So I'll check actually each number from, it can go up to 1 to n. So that's why I'll check first 1. How many comma is present? 0. So that means how actually you can decide that how many actually comma is present. Suppose we actually have 1, 2, 3. Suppose our current number is have this 3 digits. So 3 digits. So how many actually comma actually I can place? 0. So how actually know that it will be 0? That depends on that that here we have 3 digits. So I need actually to place one comma, I need actually at least 4 digits, right? So we have to say that how many digits actually I have, 3. Is it greater than equals to 4? No. So that's why it will be 0. Okay, suppose we actually have now 1, 2, 3, 4. We actually have 4 digits. Okay, 1, 2, 3, 4. 4 digits actually I have. So 4 greater than equals to 4? Yes, true. Now we will check that how many comma is present in this number. So in visualize we can know that from visual that okay, I can place only one comma here. So but in mathematical how actually I can calculate that? So it depends on that how many actually, if I divide this by 3, so how many 3 actually I can actually have. So 4 by 3, it is ultimately 1. So I can place only one comma. Got it? So let's take, we actually have suppose 5 digit, 1, 2, 3, 4, 5. So from visually I know that I can place only one comma here. After 1, 2, then actually I can place one comma between 2 and 3. But in mathematics how actually calculate this? Okay, first of all, how many digits actually present? 5 digits. Is this greater than or equal to 4? Yes. Now I want to know that how many comma actually I can present. So that depends on 5 by 3. It is actually 1. You can see that only 1 comma actually I can present. I can actually place here. Clear? So next is suppose we actually have 6 digit. 1, 2, 3, 4, 5, 6. So 6 is greater than or equal to 4. Alright. So here actually you can see that how many actually comma actually I can present here, but here actually I can place no. But if I actually divide 6 by 3, I will get 2. This is wrong. So somehow we have to handle that. So that means I need actually at least one. I need at least one digit in the at the beginning or at the left hand side. Alright. So that's why I can place only one comma here actually. Not I cannot place here actually comma here. So that's why I will actually subtract one digit here, because at minimum I should have at least one digit before the first comma from the left to the right. So that's why what I have to do first of all. So I know that okay, 6 greater than or equal to 4. This is true. So we can actually place at least one comma. Alright. So now actually I want to know that how many comma actually I can place. So that depends on first of all 6 minus 1. Why actually I am subtracting one digit? Because in the before, if we place only one comma before that, in the left hand side we should have at least one digit. So that's why I will place that first. So that's why I actually have only only 5 digits actually I have. So in between I have to know that how many actually digits how many comma actually I can place. So that depends on 5 by 3, it is actually 1. Correct? Now similarly you can check the previous test cases also. So actually you can say that I actually have 5 digits. Okay, this is greater than or equal to 4. Correct. That means we have at least one comma. Now actually first of all what to do? 5 minus 1. Okay, 4 digits. Because why actually subtracting one digit? Because this should be the at least one digit I should have before any comma in the left hand side. So that's why I'll subtract this digit cannot be actually, we cannot calculate that. So that's why 5 minus 1, 4 digits still I have. 4 by 3, it is 1. So this is also true, correct for this test case. Now for this test case, we actually have 4 digits. So 4 greater than or equal to 4. So we have at least one comma. So that first of all subtract this 4 minus 1. Okay, this is 3. 3 by 3, it is 1. Got it? For this case also, we got the actual correct output by using this formula. Correct? Now for this test case, actually our actual answer is 0. So it will be actually false for the first condition, that our digit should be greater than or equal to 4. This is not true for this test case. So it will not actually try to calculate the how many comma actually I can actually have. So it will actually return false from that point, right? Clear? So in this actually, so next suppose actually 7 digits, 4, 5, 6, 7. Okay, so how many digits is present? 7. It is greater than or equal to 4. Yes. First of all subtract one digit, because digit cannot be actually placed after comma. So that's why we actually have only 6 digits. That's why I can actually check how many actually comma actually I can present in between. So 6 by 3, it is actually 2. 2 comma actually I can place, because for I can actually place 1 comma after 3 digits. So that's why I actually have 6 digits still remaining. So it will take actually 2 comma. Correct? So here actually you can see that I will place from right to left. First comma is here, next comma is here. Clear? So in this I will actually try to calculate that, check each number from 1 to n. So what is the time complexity for this? So it will actually big of n, because I'm actually checking each individual number from 1 to 10 to the 5, and for each number it will take a constant time, that what is the length of the how many digit is present in the current number, and try to calculate that. So it will take a big of 1, or it will take big of L, or big of digits. Got it? So n into digits. So what is the maximum length for digits? Digits 10 to the 5. So 1, 2, 3, 4, 5. So digits length can go up to 6. So 6 into n maximum big of. What is this? Is the brute force approach. I hope this is clear. So if you submit this code in the first question, so it will actually work fine. Now for the test second question, or actually have n greater than 10 to the power 15. So if actually try to solve this same problem within the previous approach, so n into 6, so it will not 6, so digits length 10 to the 15, so it will be actually 16. So n is actually 10 to the 15 into 16, multiply with 16. So it will actually not work because it is greater than equals to 10 to the power 8, right? So it will not work. So we have to think out some optimal approach. So now actually observe something. Okay. So I know that 1, our answer is 0. For 2, our answer is 0. That means actually 0 means how many comma actually I can actually have for this number. So if I go up to 99, okay, first 9 still 0, then 10 still 0, I can go up to 99 still 0, okay, then 100 0, then 999 it is 0, but 100 1000, then actually I can actually place 1 comma here, right? Now 1001, then also it is 1, 1002 it is also 1 comma. So 1 comma go up to what? It usually go up to all the numbers, whatever the numbers I have, at least 1 comma, right? But suppose we reach 999, here also we can actually have only 1 comma, right? Now actually go to the next 1000, this is also still 1, okay. Actually you can see that here actually we have 4 digits, here actually also 4 digits, now it is 5 digits, okay. Now I will go up to 9999. Here also we have only 1 digit, 1 comma, correct. Now if I change the next digit 10000, still actually it is 1. Next actually if I go up to again 99, still actually I have only 1 comma. But if I go to the next higher number, we actually have 2 comma. Just observe the thing. Here actually have 3 digits, here actually have 3 digits, actually I will place 2 comma. After each 3 digits I can actually place 1 comma. So this is the first number, actually I will start getting 2 comma, I can actually place 2 commas, correct? Clear? So if I actually have suppose 1002, now actually I want to know that how many n is equal to 1002, 1002. If I want to know that how many actually comma actually I have total, so that means what is actually minimum number actually I can actually start getting 1 comma, that is 1000. So from 1000 I'll get 1 comma, right? Now next is I'll get 2 comma from 10 to the power 6, sorry, yes, 10 to the power 6, clear? From 10 to the power 6 I'll get 2 comma. So that means I'll actually start from that, from 1000 to this 1002, that means, sorry, if we actually subtract this number 999, these 3 number actually I actually have 1 comma, correct? Because this is the smallest number or the largest number that actually we do not have any, we cannot place any comma. Actually you can see that this is the largest number 999, this is how many comma actually I can place it 0, but from 1000 we actually can place 1 comma. So that's why how much number actually I have total, that the where actually I can place at least 1 comma, that is whatever the number actually I have n minus 999. Why 999? Because this is the highest number that actually cannot place any 1 comma. So that's why here actually our answer is 3. Clear? Now we suppose have another number, suppose this is a, suppose n is equal to 10 to the power 6 plus 6, okay. So I know that this is the number where actually I can start, or actually I will get start 2 commas, I can place 2 commas, right? So that's why what is the distance between this, how much number actually I can place? 7 numbers. So how to know that what is actually the number actually I can place? You can see that, just observe the thing. Here it is actually 1000, here actually 10 to the power 6. Just observe the sequence. First is 10 to the power 3, next is 10 to the power 6, 10 to the power 9, 10 to the power 12. In this actually it will actually work because I know that after 3 digits I can actually place 1 comma. So that's why, but starting number is 1000. This is the starting number where actually I can place 1 comma, right? This is the starting number where actually I can place 2 commas, 10 to the power 6, correct? So this actually I can place 1 comma, this is actually I can place 2 commas, this actually I can place 3 commas, 10 to the power 9, right? Just write this 10 to the power 9. So this is a 10 to the power 9. Here actually you can see that after 3 digits I can place 1 comma, after 3 digits I can actually place 1 comma, after 3 digits I can place 1 comma, got it? So here from this 10 to the power 9 I'll start, I can actually place 3 commas. So that's why you can see that from 1000 to whatever the number I have n minus 1000, that means n minus 1000 plus 1. This is the this actually give me the how many actually comma actually I can place, 1 comma actually I can place, right? That means I'll count, this is actually I'll count, suppose this one the first comma I'll count by this, by 1000. Okay, next if I subtract this n minus 10 to the power 6 plus 1, it will give me what, how many actually number actually I have where actually I can place this comma here, clear? So that's why whatever the number actually present, okay, if I subtract this 10 to the power 6, n minus 10 to the power 6, it will give me the how many numbers is present greater than equals to 10 to the power 6, where actually I can actually have 2 commas, right? So this will actually give me first comma, this is giving me the second comma. In this I will subtract 10 to the power 9 plus 1 of the third comma, clear? Actually just observe the sequence, how actually from the observation actually I will actually solve this problem. So I know what is the n, and from 1000, if our current number n is greater than or equal to 1000, so I actually calculated as how many actually single comma actually I can actually have. So that will be n minus 1000 plus 1. Next, this will be our, it will be added into our answer, and n is greater than or equal to 10 to the power 6. Then actually I will add how many number actually I have, that actually I can actually place 2 commas. So it will count only the number actually have 2 commas. Got it? That is got it. So this is clear. So now go to the code. So our answer, initial answer is 0. So I know that I can place at least 1 comma from 1000. 1000 is the minimum number where I can start actually place 1 comma. So that's why I will start from lower limit from 1000, and I will go up to till actually our number is, or lower limit is less than equal to n, whatever the number actually I have. If we cross the number, then that means this is not, we cannot, suppose the current number is suppose this, suppose 1 2 3 4, and we have reached 10 to the power 6. Can we actually place any 2 commas here actually in this number? No, because this number already, whatever the number actually I want to place, that is 2 commas, this number already crossed actually the whatever number actually I have n. So that's why we cannot place any commas, new commas. So that's why I will stop that there. So that's why I will go up to less than equal to n. And next number is, next number, that means suppose I know that it will go up to 3 by 3 digits. So that will first it will go start from 10 to the 3, then it will 10 to the 6, 10 to the 9, in this way. So that's why I have to multiply with 1000. Next I have to multiply again 1000. Clear? This is the next number, next smaller number from where actually I will get next greater number of commas. Actually I will get 1 comma, actually get 2 commas, actually I get 3 commas. Got it? So that's why to count that I will start jump from here. Right? So that's why next number it will be multiply with 1000. So for this current number, how much number actually I actually have this first comma. So that will be whatever number actually I have n minus lower limit, that means 1000 plus 1. Why plus 1? Because the I have to count the 1000 also, because 1000 is also give me one comma, right? So that's why I have to handle that. So n minus 1000 plus 1. Ultimately, we are actually calculating with the 999, 999, correct? So that's why I have to handle that. Similarly, I go to the next number. Suppose next number is, suppose, let's take the example. This is suppose next our number n. Okay, so 1 2 3 4 5 6 7. So next I will go to the next number, where I will start getting two commas, that will be 10 to the power 6. So 10 to the power 6. Okay, 10 to the power 6. So here actually you can say how much number actually I have, that actually I can place two commas. That is, if I subtract this plus 1, 5 plus 1, because this number also will actually give me two commas, right? So that's why I have to subtract I have to add plus 1 also for this current number 10 to the power 6, for the number 10 to the power 6. Clear? So how many number I have, or I can place two commas, that is depend on 2 3 4 5 6 7 plus 1, ultimately 2 3 4 5 6 8. Clear? Got it? So after I will continue up to actually our number is less, our number is greater than used to the limit. So ultimately, after checking all of that, return what are the total number of commas that I have seen, or I can place, return that. Actually, you can see that what is the time study for this. Usually it can go up to 1000, then 10 to the power 6, 10 to the power 9, 10 to the 12, 10 to the 15. So it can go up to 10 to the power 6, 6 times maximum, right? Because it's jumped by 10 to the power 3. So that's why 10 to the power 15 is the maximum value in, and 10 to the power 15 by 10 to the power 3. So it can jump maximum 5 times. Clear? Got it? I hope this is clear. I have shared this code in the description. You can check that. You have any doubt, any suggestion, you can comment on that. And if you like the video, please like the video. And if you not subscribe, please subscribe channel. It motivates me to make videos regularly for this channel. Thank you. Bye bye.